Please make sure you have your copy of the assignment Volumetric Titration, a Better Analysis of Vinegar. Say the last time we were analyzing the vinegar, we were trying to find out how much acetic acid there was by taking a cup of vinegar and adding a little bit of baking soda at a time. Each time we added a little bit of baking soda, it would make a fizz as long as there was acid in the mixture. We mixed this out until all the fizzing was gone. Then we add a little bit more baking soda. Each time we're using up some of the acid that's in the mixture. Eventually, when you use up all of the acid, the next time you add the baking soda, there's no fizz. That's how we know when to stop. We measured how much baking soda we used, and we calculated from the mass of baking soda what was the mass of acetic acid in the vinegar to compare to what it says on the label. It says on the label that it's 5% acid. Our results showed much different results. Often our results are much higher, and that's because when we take that last step to find out how much acid is in there, when we take that last step to see that there's no more acid, usually we add a lot more than we need to. We go way past the end of what we're trying to measure. So this time we're going to try again, but instead of adding a solid from a cup, we're going to add a mixture. We're going to add potassium hydroxide. Potassium hydroxide is a solid substance, but what I did was I made a solution by mixing it with water, and we're going to add it 1 milliliter at a time so that we have much more control over the amount that we're adding. The amount that we're going to add with each milliliter is only 0.010 grams, a very tiny amount. That's the smallest amount that you could measure with the balance. And it would be very hard to add that small an amount with any control by dumping it out of a cup. So this volumetric technique is much more exact and much more accurate. Now, please take a look with me at the procedures. On the front, we're going to follow these procedures, and then on the back of the first page, we'll keep track of the one piece of data that you're going to collect, and then we'll do some calculations. The first step is to take yourself a small white plastic cup and then fill it halfway with the potassium hydroxide solution that we're going to use. So you just need about a half a cup, maybe not even. And then set that aside. Make sure to put the top back on the cup. This is the stuff that I'm going to be adding to my vinegar. The second step says I'm going to add 5 milliliters of vinegar to a cup for my analysis. Now on the pipette that you're going to use, there's one line and there's a note that says stop here so that you know where to fill it up to. So what you'll do is you'll take the vinegar and then put this big pipette down into it and then draw by pulling on the syringe until the liquid level comes up to that line where it says stop here. That will be exactly 5.00 milliliters of vinegar. Put that into the cup that you're going to use to do the analysis. Every person in class today has the opportunity to do this analysis. There's more than enough materials for each person. Now the next thing we're going to add, this is the key to the analysis, it's a color change indicator called phenolphthalein. Instead of looking for fizz, today we're going to look for a color change. Phenolphthalein is a clear colorless solution. I'm going to add 5 drops. 1, 2, 3, 4, 5. It's a clear colorless solution that reacts with the potassium hydroxide and turns pink when all of the acid in the mixture is gone. So now I've got a little bit of vinegar with my 5 drops of color change indicator, and I'm going to add 1 milliliter of the potassium hydroxide at a time. That means draw the liquid up to this line and stop, and then add it to the cup. So that'll look like this. I'll draw the liquid up to that 1 milliliter mark, and I'll put it in, and then I'll swirl. What I'm looking for is a pink color change. When you're adding the potassium hydroxide, each milliliter uses up some of the acetic acid that's in the mixture, so there's less and less and less of it. And then when all of that acetic acid is gone, the next bit of potassium hydroxide you add doesn't have any acid to react with. Instead, it has the phenolphthalein, the color change indicator, to react with, and then it will turn pink. So I'm going to keep on adding this just a little bit at a time, and I'm going to count how many milliliters I add, so make sure to keep track. Each time you add it, we're looking for that pink color change. Now there's one that I started earlier, so I can show you how it looks when you get closer to the end. Let me zoom in down on that one. Okay. Now I'm going to add a little bit of this phenol, the sodium, potassium hydroxide, another milliliter. And when I add it, you'll see a pink color change. You're looking for a permanent pink color change. It has to turn pink and stay pink. I see some pink when I squirt this in here. That means that I'm getting very close to the end of the acid. Once all the acid is gone, the next squirt that I put in will turn the color pink permanently. So I'm still counting how many I'm putting in. That's the piece of data that you're going to need to do the analysis. Okay, I'm getting much closer. I can tell I'm getting closer because the pink is harder to swirl out. Nope, nope, not quite there yet. Try another one. Is it? Oh, that was pretty close. So if it's hard to swirl out the pink color, you know that you're very close to the end. Add your last bit carefully. Okay, so that's what's going to happen when it's all done. When you've used up all of the acid that's in the vinegar, then it will turn pink and stay pink. And what you need to know is how many of these did you add? How many milliliters of the potassium hydroxide did you add? Because that's your data for the analysis. We'll do the analysis together once you're all done. What you can do with the materials when you're done, the big cup can get dumped in the sink and tossed out. The little squirty pipettes can get put back in the cup where they came from. And if you have any extra potassium hydroxide solution, you don't have to dump that down the drain. Let's just pour that back where you got it. And then you can throw away the little cup.